Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. I'm Steve Brahosky, and I'm a Connector Business Development Manager at TTI, and have been in the electronics industry for over 30 years, 4 here at TTI. In this episode, we're welcoming Corey Jenkins, Senior Director of Business Development of HARTIng. Our subject matter today is why hardwiring has no place in modern factories. Before we get in, Corey, would you mind introducing yourself to the audience and sharing some of your experience at HARTIng?
Yeah, sure, no problem. I'm also a business development manager here at HARTIng. This is going on my 24th year here at HARTIng. I've had many different roles: product management, engineering, business unit manager, that sort of thing. So I've been involved in connectorization, cable assembly production. That's kind of been my last quarter century here. So now I'm focused mainly on kind of the new emerging markets like data center and semiconductor. But yeah, that's my role.
Thank you. Welcome, and we really appreciate you sharing some insight with our audience today. So the subject matter being why hardwiring has no place in modern factories. Can we maybe begin with what is hardwiring and how has it historically been used?
Yeah, so hardwiring, it kind of means kind of the same thing at the core. So hardwiring, in my mind, is not using a connector. So bringing a cable or conduit or wires into a cabinet, let's say, or a motor. And in most cases, at the end of that cable is a wire ferrule or a ring lug going right to a terminal block. So think of like a one-time connection. I think a good analogy I use is like your panel inside your house, right? That's hardwired. That's kind of how we describe it.
Okay. So it's kind of like point-to-point wiring. Sometimes I've heard that terminology be used in factory automation or in electrical panels within factory floors.
Yeah, it's a good way to describe it. Point-to-point, kind of one-time connection is basically hardwiring. Something that, right, you're never going to disconnect, never going to fail, that type of concept.
So why would you choose, or why has that historically been used in place of connectors?
Well, I mean, if you have a situation where, right, we work for a connector company and we like to think connectors can be used everywhere, but sometimes a connector doesn't make sense, right? If you're in a position where you have something that's never going to fail, is going to be modular, right? It's all manufactured in the same place. You're not so much concerned about the assembly time and that sort of thing, and maybe it's a throwaway item, if you will, or you're never going to maintain it, and those concepts are not really that common in the machinery world, right? You want it to be modular. You want it to be maintained. You want it to be quick assembly time, no errors. So it's not really the real life environment when you think about, the machinery world or the data center world. So yeah.
Okay. So that helps me. Having come from a connector background myself, working for a manufacturer before joining TTI, I'm certainly got a bias towards connectorization. So why would you say connectors are a better option? I think you kind of hit a few of the points there, but How would you characterize the main reasons why connectors would be a better option than hardwiring?
I mean, to keep it in like a layman's term, plug and play, right? People are familiar with that term. So you make whatever you're designing, whether it's a data center or a machine or a train or whatever it is, plug and play. So once you do that, the advantage is, right, it streamlines your engineering, your design process, your building process. It also reduces your startup time and reduces the risk that when you go to assemble it on site at your customer, that it's going to be done the right way the first time. Right. And also, if you as a manufacturer OEM are responsible for your own maintenance or warranty costs, it drastically reduces all of that. Right. Think of an item that fails. Maybe they can send it back. You send a part working, and they plug it in and it works. At the end of the day, that's just a decrease of their downtime, right, or increase uptime, however you want to say it. So that's kind of the main reasons of using a connector.
The fact that it is connectorized means you can connect and disconnect it by virtue of the connectorization. And I would have to believe, life cycle in terms of how many times you'd want to change, I'll say the wiring scheme within a piece of equipment or within a control box would have a compelling reason as to why you'd want to maybe use connectors as well.
Yeah, I mean, you think that like a common scenario I'll use machinery as an example. Most machine manufacturers, and I'm using the term machine loosely, right? A machine, you can design a core part of your equipment, and you can have the modules around it. Modules can be whatever. It depends on the industry. But then you can commonize your core design of your machine and then add on or plug and play all of those different options, right? And one machine may have 3 of those options, one may have 10, but it doesn't change your design, so to speak. And you can easily plug and play and maintain that equipment.
So how would installation time come into play here in terms of helping with the decision-making process between hardwiring and connectorization?
Yeah, so the use of connectors, what it really does is it allows you to assemble the housing side or the panel side and the associated cable assemblies in a controlled manufacturing environment, right? Think of like a production line. Everything's tested. So it really reduces the assembly time itself of the actual termination of the wires, but it also then, when you go to deploy on site at your customer, which is a different environment, right? It could be outside, it could be dirty, it could be noisy. You don't have to do the actual wiring on site. So it drastically, reduces the startup time for that equipment.
Okay.
I had a customer one time in the state next to us. He said, "Hey, your connectors, they they let me sleep at night," is what he kind of told me, because he goes, "I know when I have all the execs flying from 4 different countries to see my equipment run, that I've already tested it, and I know when I plug it in, it's going to run."
Wow.
There's no questions of miswiring and that sort of thing. So
that's interesting. Kind of a funny story, especially connectors being able to let you sleep at night. Having spent my entire career in this industry, I guess it's given me both some. I was going to say it's also led itself to some sleepless nights, but regardless, it's a good little caveat there. So, how about total cost of ownership, and how does that maybe impact the decision of connectorization in this space?
I mean, we've done a lot of look into total cost of ownership, right? It's a term that's used widely, and we could easily, say that the total cost of ownership is really, really high in a connector, which it is, but it totally depends on the situation, right? But at the core of it, the minute you connect and disconnect the connector one time, you've paid for the physical connector.
Okay.
Right? Because connectors, they cost money, so you have to be able to account for that. But once you connect and disconnect, you've paid for that. That's without realizing any of the benefits that we just talked about.
Wow, that's
right?
fascinating. Okay.
And we have an app that's on the website where you can kind of take a look at that. But regardless of whether you type in your labor rate or number of pins, it doesn't really affect the story. Connect, disconnect, it's paid for that connector.
Wow. That's pretty cool.
And then you add on like everything we talked about: maintenance, reduced installation time, error-free, modularization, that sort of thing. Those are all like on, added benefits on top of the cost of the connector.
Well, it sounds like plug and play, as you described it earlier, is becoming more and more common, more prevalent. Mm-hmm. And maybe you can provide some examples of industries that have adopted it at an earlier rate than others, but maybe share some insight in terms of the trends that you're seeing.
Yeah, I mean, one of the trends that I'm personally involved in here is, everyone's heard of artificial intelligence. They've heard of data centers and the growth in that market, right? So what the term that they use is critical path. They want installation time to be minimized with reduced risk, and anything that's in that critical path concerning timing, they want to connectorize, right? Because they need to expand quickly. So all of the power distribution in that space, is connectorized, so that's one of the major examples. Another example is in the machinery market, right? Is as equipment is becoming, let's say, more complicated, right? I don't think you could find a piece of equipment without Ethernet on it, right? Which wasn't the case 20 years ago. So almost everything, it doesn't matter the industry, has some intelligence in that machine. So you have a combination of Ethernet control signals and power on that machine. And most people are familiar with, right, the RJ45 like on your computer. So there's connectorization in every machine anyways. And then you can adopt that same philosophy with all the power and everything else that goes with it. So the trend is to connectorize as much as you can. Not just the communication, also the power, and kind of the whole machine. You're seeing it even to like extremities of like the end of a robot, right? Even the cameras, the vision, the sensors and that, those are all being connectorized too. So all the way down to the incoming power. It's not really limited to like one industry or one section. Connectorization is kind of in all markets.
You mentioned the term modularity earlier. I think you mentioned it in the context of machine modularity. Could you maybe share some insight on how that's impacting connector selection?
Yeah, so if I'll rewind about, I guess I mentioned I've been HARTING 24 years. So we had at that time many connectors that were defined number of pin counts, right? This one is for 3-phase neutral ground motor, done, right? This one is for a 20 pins. Well, in today's world, that doesn't work as much, right? People want to customize everything, right? Not just connectors, but everything in their life. So one of the most popular connectors that we have is our modular series that allows you to pick. We use the kind of analogy of like Legos. I think there are like 200 or so different modules that we have, and you can pick and choose, like I was talking about before, whether it's Ethernet or power, and put it all into one connector. But what also helps is that you can leave maybe a blank spot in that connector, so you can change it easily without changing the footprint of your panel or changing any total re-engineering of your equipment, which allows for future expansion of your equipment without like a wholesale, re-engineer of it.
So that, like what you just described, is like your HAN connector, the domino modules that you can put inside the HAN connector. Would that be an example of that? Okay.
That's right. So so the domino module is basically an extension of our modular series. We've kind of minimized or we've cut the size of the modules in half to allow like double the flexibility. Like instead of a module being one slot, you could fit 2 modules in the same space as you could fit one before. So it allows you to make the connector as small as possible without any wasted space.
Yeah, that I can see how that would play a part in the decision-making process of if someone has gone through the evolution of going from hardwiring to connectorization. You hear a lot in this day and age about labor shortages, and more specifically, and I'll say skilled labor or electricians that are becoming harder and harder to find. I assume that plays a part in the decision that a customer goes through when they decide what to do in this area.
Yeah, I mean, so here's the answer is completely yes, right? The more plug and play the equipment, you don't have to account for skilled labor in the region that you're deploying your equipment, right? It's no longer a concern at that point. So there are, certain areas where something gets deployed and they can't find enough electricians to do the installation. I mean, that's a reality in some of these situations. So the amount of pre-work that you do wherever it's being assembled, like an example is, let's say the cabinet is being made in Poland, but some accessory is being made in Texas, right, in Fort Worth. But they're coming together being installed in Florida, right? You at that point you would have to have some skilled labor, but if you use connectors, you can assemble the cabinet in Poland, 100% test it. You assemble the module or whatever is going to be connecting to it in Fort Worth, and then when it arrives in Florida, you put it together. You don't have to worry about, organizing that portion of the labor, if you will.
That would save a lot of money and a lot of time, and save a lot of headaches for sure.
Yeah.
So look towards the future. What's the future of connectorization, and what role will HARTING play as an innovator, I would say, in industrial connectivity? Are there standards that are coming into play, or what do you see down the pike, so to speak?
I mean, I see kind of three things, right? We see everybody wants more power in a smaller footprint. They want higher speeds in a smaller connector, and they want the connectors to be smart. They want them to measure more than just the signal going through it, right? They want to measure, that the connector is plugged into the right space. So and sustainability. So I'd say those are kind of the four things. It says like miniaturization, intelligence in the connector, and the sustainability is becoming a more recent trend, right? So what we're doing is we are designing connectors that are more efficient, connectors that have higher speeds and a smaller footprint, and we have more recently made a lot of our products more sustainable by our, the way we procure the plastics and that sort of thing. So Those sound like small trends, but trying to squeeze more power in a smaller footprint, sometimes you're changing the materials used, right? You're trying to change the laws of physics, which are impossible, but you're stretching it, right?
Absolutely. So I assume there are standards bodies that surround all of this, that usually in the connector space, but specifically to this part of connectorization, what standards bodies do you get involved with?
Well, for sure, UL in the States. Globally, IEC is another one, and those are kind of just higher level connectorization type specifications. And then there are certain ones that are, unique to certain markets, right? More so like as you make cable assemblies, which we do, sometimes the assemblies are needed to be listed, right? And listing is another level of kind of approval for the assembly. So UL is important, the IEC, and then there are some local standards for each different country in many cases that we're involved with.
And then you've also got beyond that, within certain, I'll say, communications protocol, you might have standards that surround that in terms of the form, fit, and function of the part itself and how well it behaves electrically, electronically. So a lot of activity surrounding this, I'm sure, as the industry continues to evolve, and knowing that Harting is on the front end as an innovator, you play an important role with setting the stage and with setting the standard that others will eventually have to adopt and adhere to.
Yeah, definitely.
Cool. Anything else you'd like to add beyond what we've shared so far, Corey?
I mean, I think we've covered most of it. I would like to, at the core, people think, connectorization is plug and play, but at the end of the day, we help people design, build, test, deploy, and upgrade their equipment easier and faster, right? Without risk. That's kind of what we do at the end of the day, whether it's power or signal. And being at like a pioneer in the connectivity space, we are pushing the limits, right? When it comes to intelligence in the connector, reduction of the energy lost in the connector, right? Increased efficiency and miniaturization, right? We're really pushing the envelope of that. So yeah, that's kind of at the core what I like to say.
You certainly have provided some really compelling information to share with our audience. We appreciate you sharing your knowledge and insight on hardwiring and the connectorization to the factory floor, and how industries and companies are adopting this. Your comment about, you made it once and it's paid for itself, I thought was really compelling in terms of the justification for doing this, along with the other aspects of what this connectorization in across industries can do for our customers, our collective customers. We do look forward to future episodes with Harting on emerging markets that help shape the connector development and usage in years to come. And we thank the listeners for plugging in with us today, and ask that you tune in again to the next TTI Distribution Download.
Thank you, guys.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.